Hello and welcome. Today we're taking a closer look at a really fascinating piece of tech, the SAC 002 combination probe. We're going to be unpacking everything from its technical datasheet, that's document D23642, to see what makes this thing tick. And trust me, it's got some serious tricks up its sleeve.
So it really all boils down to this one question. You look at it, and it seems like a straightforward, wall-mounted sensor. But once you peek under the hood, you find a device with multiple personalities. One that's built to adapt to almost any situation you throw at it. And that's what makes it so special.
But before we get into all that flexibility, we've got to understand its foundation. What does it actually do? At its heart, the SAC 002 is designed for one main job: to very precisely measure three absolutely critical environmental parameters.
First up is temperature. It boasts an accuracy of plus or minus 0.2 degrees Celsius. For professional building automation, that is impressively precise.
And it doesn't stop there. Next, you've got relative humidity accurate to within just 2%. Again, that's a solid professional-grade spec. And rounding out the trio is air quality. It measures CO2 levels with a precision of plus or minus 50 parts per million. That's right in the key range you need for managing indoor environments.
So when you see the full range and accuracy specs all laid out together like this, it makes one thing crystal clear. This is no consumer gadget. These are the kinds of numbers that build real confidence for serious, commercial-grade environmental control.
Okay, now let's get to the really cool part. This is the core of what makes the SAC 002 a true chameleon. It isn't just a sensor. It's a multi-protocol, multi-function tool that can basically shapeshift into 4 completely different devices, all from this one little box.
We're going to walk through these 4 personalities. Each one completely changes how the device gets its power and what it can do, which gives installers and system designers just incredible flexibility.
First up, we have Modbus mode. Think of this as the full power, all features unlocked setting. Yeah, it needs an external 12 to 24 volt power supply, but in return, you get everything. All the data over the Modbus network, plus it activates the 3 analog 0 to 10 volt outputs at the same time. The whole shebang.
Next is M-Bus mode, and this one is super convenient. The sensor is powered directly from the M-Bus communication line itself, so no separate power cable is needed. Super clean install. The trade-off? By default, the analog outputs are off. But, and this is a nice little touch, if you do connect an external power supply, they spring right back to life.
Third, you can just forget the digital protocols entirely and run it in pure analog mode. Here, it acts just like a classic transmitter, pushing out the temperature, humidity, and CO2 values over its 3 separate 0 to 10 volt channels. This mode, as you'd expect, needs that external power to drive those outputs.
And finally, this one is just brilliant. NTC 10K mode. In this mode, it needs no power at all. It just uses 2 terminals to act exactly like a standard passive NTC 10K temperature probe. This is an absolute game changer for retrofitting older systems that are just looking for a simple temperature input without you having to overhaul the whole controller.
So that is a lot of flexibility. But what does it actually look like out in the real world? Well, the datasheet gives us 2 perfect examples of how this chameleon sensor gets put to work in actual building automation systems.
Okay, scenario 1, direct control. You'd connect the sensor using Modbus right to a system controller, something like a YLC880. In this setup, its real-time data on temperature, humidity, and CO2 is fed directly to the controller, which uses it to make decisions on the fly, adjusting ventilation, turning on the AC, that kind of thing.
Then you have scenario 2, which is all about system monitoring. Here you might connect a bunch of these sensors using M-Bus to a gateway, like an EHC602. That gateway then makes each sensor's data available as a virtual device on a bigger network or a cloud platform. This is perfect for system-wide monitoring, logging data over time, or even building custom control logic. Now you might be thinking, a device this powerful has got to be a headache to set up. But it's actually designed with the installer in mind. Let's take a look at how you actually configure this thing and some of the smart features that make life a whole lot easier.
The setup is surprisingly simple. You just plug a PC into the sensor's micro USB port,
Fire up the free Coster Tools software, and right from there you can set your Modbus or MBus addresses and the communication speed. No crazy programming needed. It's pretty much point and click.
And check this out. Here is a feature that any installer is going to absolutely love. It's called Individua Disposito, which just means find device. Imagine you have a dozen of these things wired up on the same bus. Instead of guessing which is which, you just select one in the software, click a button, and a little LED on that exact sensor starts flashing. No more guesswork. It's super handy.
The sensor has also got some brains built right in to cut down on maintenance. The CO2 sensor features something called automatic background calibration, or ABC. Basically, if the room it's in is guaranteed to get fresh air at least once a week, the sensor uses that low point as a baseline to automatically correct itself for any long-term drift. It keeps itself accurate over time, all by itself.
So it's really important to step back for a second and ask, what does all this flexibility and integration really mean? This is more than just a convenient gadget. It really points to a much larger trend in how we design and manage our buildings today.
For the designers and installers out there, the value is just immense. Having one single device that can adapt to different protocols, different wiring, different power situations, it means you stock less hardware, you have simpler wiring diagrams, and ultimately, you bring down project costs and complexity. It's a tool that has an answer for pretty much any curveball a job might throw at you.
And this sensor really illustrates where the whole industry is going. It leaves us with a final thought to chew on. As we focus more and more on healthy indoor air and on squeezing every bit of energy efficiency out of our buildings, how will these highly integrated, flexible, and, I love this word, loquacious or talkative sensors continue to transform the way we manage our spaces? They're becoming the key to creating buildings that are genuinely intelligent and truly responsive to us.